Hello everyone, welcome to TSAT Group 1 classes. In the previous class, we have discussed about the satellites, natural and artificial satellites. We've also discussed about the orbitals. We've also talked about the launch vehicles of India, and we've also talked about why do we use these launch vehicles, and we have also talked about why we have different stages in the launch vehicles. And today we will discuss about the rest of the things. In this class, let us see what we have to do is, we have to talk about the launch vehicles of India. We have different types of launch vehicles. You can see here we have SLV3, we have ASLV, PSLV, and then we also have a GSLV, Mk2 and Mk3. See, satellite launch vehicle, this SLV3 is India's first satellite launch vehicles. The fuels that we use here is a solid fuel. It has 4 stages and it weighs 17 tons and 22 meter height, and it's capable of placing a 40 kg class payloads in the low Earth orbits. So it was successfully launched on July 18th, 1980. And then the next satellite launch vehicle is ASLV. So this is an augmented satellite launch vehicle. The liftoff weight is 40 tons. It has a 24 meter tall and it has 5 stages. In all the 5 stages, we will be using solid propellants. The payload capacity is up to 150 kg satellites, and this 150 kg satellites it can put in a circular orbits around 400 kilometers above the Earth. The first developmental flight took place on 24th March 1987. And before going to learn about the satellites, we were talking about solid propellants. We were talking about various stages. What is this fuel all about? Now let's learn some fuels, what kind of fuels that we'll use, and then we'll talk about the launch vehicles of PSLV and GSLV. So the fuels, we will talk about MMH plus MON. So MMH is nothing but it's a monomethyl hydrazine. There you can see what monomethyl hydrazine is. It is actually a clear colorless hygroscopic liquid. So this absorbs moisture. Hygroscopic means it actually absorbs moisture from the air. It is actually a mild alkaline base and a very strong reducing agent. So it is soluble in hydrocarbons. The mixed oxides of nitrogen, that is MON, are solutions of nitric oxide in dinitrogen tetroxide or nitrogen dioxide. That is N2O4 and NO2 is mixed with MMH, and these two will become the fuel of the, it is nothing but it's a fuel, or we can call it as a propellant. So it is issued as an oxidizing agent. So this is another fuel that we'll use is HTPB, that is hydroxyl terminated polybutadiene, that is HTPB. So this is used in composite solid propellant. So what do you mean by propellant? We were using this word propellant and fuel. Propellant is nothing but it is a mass. Expanding this mass is actually create a thrust. The thrust is the reason that the satellite will be taken into the space. So HTPB is synthesized through both free radical and ionic polymerization methods. So this HTPB actually binds the oxidizing agent like ammonium perchlorate or ammonium nitrate. So upon this oxidization, it actually creates thrust, and thrust is the responsible for satellite to move into the space. And the another important fuel is UDMH and N2O4. This N2O4, the nitrogen tetroxide, it's became the storable liquid propellant. So this is the structure of the UDMH. So this UDMH is nothing but unsymmetrical dimethyl hydrazine. Dimethyl means this is a one methyl and this is another methyl. These two, we have two methyl, that's why it is called a dimethyl, and this is a hydrazine. So this is another hypergolic rocket fuel ingredient. It's often used as a bipropellant in combination with an oxidizer, that is a nitrogen tetroxide. So UDMH plus nitrogen tetroxide, this N2O4, is the fuel. And now let us move on to another one, that is a methane and liquid oxygen, that is LOX, liquid oxygen. Liquid oxygen and methane engines, or this is a liquid oxidizer and methane, these are the engines. This LOX is currently regarded as a worldwide, in the worldwide, as a propellant combination for future rocket propelled vehicles, because they are future rocket engines, fuels. It is because methane is abundantly available in the nature, and also methane is synthesized using water and carbon dioxide in space. See, this carbon dioxide is a global warming agent. If we can capture the carbon dioxide from the environment, it actually, we have a double advantages with this. So we will be reducing our carbon dioxide in the atmosphere, and also we will be using this carbon dioxide to synthesize methane. That's why this methane and liquid oxygen is a future fuel. And apart from this, this is actually a very low cost in nature. Since it is a low cost, and also it is used in reusable engines. Most of these reusable engines are using this methane and liquid oxygen. See, in India, we have also tested this liquid oxygen methane engine technology, was demonstrated in October 2020. Now let us move on to the engine. What kind of engine that we use? We have the first engine that we have used is the 𝗧𝗏𝗏 engine. The 𝗧𝗏𝗏 engine is a liquid fueled rocket engine. It's conceptualized and designed by the Liquid Propulsion System Centers, that is 𝗹𝗶𝗁. That is 𝗹𝗶𝗁 is in Valiamala in Kerala, and this is responsible for design, development and system engineering of the high performance space propulsion systems, that's employing this earth storable cryogenic propellants for ISRO's launch vehicles and satellites. So this 𝗧𝗏𝗏 engine, there is an interesting story about this 𝗧𝗏𝗏 engine. 𝗧𝗏 means it is a VIK, that is taken from Vikram, and then A is taken from Ambalal, and this S is taken from Sarabhai. Vikram Sarabhai is a pioneer in this. So Vikram, on his name we have taken that word 𝗧𝗏𝗏. In this 𝗧𝗏𝗏 engine is actually we have re-engineered using the Viking engine. This Viking engine is actually the France supplied this first engine to India, and using that engine we have actually developed this 𝗧𝗏𝗏 engine. So that is another important thing that we have to understand. France is the country that supplied engines to us for the first time. This you can see here, the 𝗧𝗏𝗏 engine. And then there is another engine that we use is a cryogenic engine 20. This cryogenic engine is developed by ISRO. It is actually a liquid propellant engine. This is developed by high thrust cryogenic engine to be used for the upper stage of its heavy lift launch vehicle called GSLV Mk3. So because this since we are using this liquid propellants, this has high specific impulse. That means per kg or per gram fuel, it actually gives high thrust. This is rocket fuel performance is measured by this property called a specific impulse. Since we have high specific impulse, that's why we are using this liquid fuels. So for liquid fuels, we need a specialized cryogenic engines. That engine is nothing but cryogenic engine C20 that India is developing indigenously. And then we will talk about, since we have also talked about the fuels, now let us talk about the launch vehicles. Another launch vehicle that we will be using is this Polar Satellite Launch Vehicle. This is the third generation launch vehicle. First one was SLV and then ASLV, and this is a PSLV. It is a third generation launch vehicle. This launch vehicle has its specifications, like you can see. The height is of 44 meters and it has a diameter of 2.8 meters. So what is this number of stages? This number of stages is 4. What is this? It's a 4 number of stages. The lift-off mass, that is the mass that when it lifts off from the earth, that is from the 𝗧𝗦𝗔𝗧, it has its weight of 320 tons. So this Polar Satellite Launch Vehicle has a variance. That is, we have 3 variations, that is PSLV-G, PSLV-CA and PSLV-XL. The first flight it took is on September 20, 1993. So we are talking about the stages, number of stages of this satellite launch vehicle. Last time we were discussing about the stages and what in each stage we will discuss about this. This is a PS4, that is a 4th stage. 4th stage has a liquid fuel. What it is? It is a liquid fuel. What is this liquid fuel is? The liquid fuel is MMH and MON, and it produces the maximum thrust is a 7.2 into 2 kilonewtons. And the next stage is a 3rd stage. See, 4th stage means it is the uppermost stage. This is the last stage of that launch vehicle. And the PS3, that is the 3rd stage, uses a solid fuels. So what is the solid fuel? That solid fuel that is used is HTPB. So what is the maximum thrust is this 240 newtons. So another 2nd stage is a liquid fuel, and what is the liquid fuel? Liquid fuel is this UDMH N2O4, and it actually have 799 kilonewtons. And the first stage is again a solid fuel that uses HTPB. HTPB, apart from this, this has a strap-on motors which produces 719 kilonewtons. So what this satellite actually keeps? Satellite actually puts this Polar Satellite Launch Vehicle puts satellites on the orbits, right? So what are those orbits? It actually puts satellites in SSPO, that is Sun Synchronous Polar Orbit, that is SSPO, and GSO, Geosynchronous Orbit, and this LEO, that is Low Earth Orbit. That is another one is GTO, that we have all discussed about all these things in the previous class. GTO is a geostationary transfer orbit, and this HEO is nothing but high Earth orbits, and also it is used for lunar orbits. Lunar orbits means the orbits, the Chandrayaan one, we have used this. And now let us talk about another satellite launch vehicle, that is GSLV Mk3. This is the latest one. GSLV is nothing but it has its height of 43.43 meters. So what is the diameter of this is 4 meters, which means what a 4 meter diameter means, it is the diameter of this. This is a 4 meters, and what is the height of this? This is the height that it would be around 43.43 meters. So that you can actually see this. This is a satellite launch vehicle, so which has a 4 meters, and then this, and then there is another one is heat shield, that is of 5 meter diameter. That's payload fairing. Okay, and this has 3 stages. So what is the lift off mass? Lift off mass is 640 tons. So what are those 3 stages? This three stages is the cryogenic upper stage. Cryogenic upper stage is the one, this is the last stage. This actually uses a liquid propellant, a liquid fuel. Instead of fuel, we always generally call propellants. So this has a 28 tons fuel. That fuel is nothing but liquid oxygen and liquid hydrogen. And the next stage, that is the second stage, is a solid rocket boosters. We have 2 boosters. These 2 boosters will have S200 solid rocket boosters. This actually uses solid propellants. The solid propellants, so what is a solid propellant? This is HTPB, and it uses 205 tons of HTPB. And the next stage, that is the first stage, that it is a core stage, that we also call it as core stage. This core stage is a liquid propellant is used in this core stage, and 110 tons of UDMH plus N2O4 used as a propellant. So these are the various stages, and we have types of the propellant, that's fuel, and then we have also used what kind of fuel that we'll use in each stage. And then where do we use this GSLV? GSLV used to put the satellite in this orbit, that is GTO or LEO. It can be used for both. If we use it for GTO, the maximum payload is 4000 kg. If we use this for LEO, we will use for 8000 kg payload. We know that why this is less here, why we more here payload, because this payload, this LEO is a low Earth orbit, it would be around 600 kilometers, whereas GTO has 35,000 kilometers. If you want to take a longer distance, you need to have a less payload, and if you want to take a lesser distance, we will be using more payload. That is how it works. So this is about a GSLV Mk3. And then now let's move on to the another one, that is applications. So what are the different types of applications that we use? See, this India, we have one of the largest constellation of satellites. These satellites are used in various applications. That is, these are the applications. That is Earth observation applications. That means we will use these satellites to observe the Earth, and then we will also use for satellite communication. Satellite communication, and we will also use this for disaster management support, and we will also use this for space science and exploration part. To explore the science, we will also use these satellites. These are the various applications. Now let us learn one by one about these things. So applications. Now Earth observation, meteorological satellite system and its application. So this for Earth observation, we use this IRS, a system of satellites. This Indian remote sensing, this is the satellite systems. The satellite systems were first launched in 1988. This system of satellites are used for Earth observation. So these are initiated with launch and commission of IRS-1A, that is the first operational Indian remote sensing satellite, was in 1988. So some of the most prominent applications are the agricultural crops, agricultural crop inventory, and then water resource information system, and then groundwater prospects, and then forest working plans, biodiversity, coral mapping, and then potential fishing zones, and then ocean state forecast, rural development, urban development inventory, and the monitoring of glacial lakes and water bodies. And this also use this location based services using 𝗪𝗂𝐼C. We'll talk about 𝗪𝗪𝐼C constellation in detail. We'll also use for this disaster management support programs like for cyclones, flood mapping and monitoring. And also use this for landslide mapping and monitoring. And we'll talk about also used in agriculture, drought, forest fires, earthquakes, and extreme weather monitoring and experimental forecasts and so on. These are location-based services that we will use. You can see here, I would like to talk about this IRS data here, the growth progression of this wheat crops monitor using this time series of IRS data. You can see that in the mid-November, the picture is like this, and the early December, the picture is like this, and the early January, the picture is like this, and the mid-February, the picture is like that, and the mid-March, the picture is like this. Based on the analysis of these pictures, we'll actually forecast what kind of wheat crops are grown, or what kind of how much production we might get based on the historical data, and the analysis of these images will come to a conclusion that how much agriculture crop produce can be produced, and what are the water resources information like groundwater, what would be the groundwater, whether the groundwater is depleting or not. So how much is depleting, and if the groundwater increases, how much the groundwater is increases. All these things actually forecasted and given a proper information using this kind of pictures. And you can see here, for one more example here is, this is actually about the weather forecast. So weather forecast is actually based on the pictures that are generated using the satellites. You can see this a thematic information. Based on this information, they will forecast the cyclones, they forecast the kind of wind speed. Based on the wind speed, when the cyclone is going to come, and what is the destruction it is going to takes place. So all this information is given based on the inputs taken from the satellites. So this is, and another important thing is, what are the satellites that are in service about this Earth observation. So these are the various satellites that are in service for Earth observation itself. That is a Cartosat, Cartosat 2A, a radar imaging satellite, that is RISAT-2, OceanSat-2, and the ResearchSat-2, and Megatropics, and the Cartosat 2B satellites with Argos, that is, and Altica, that is SARAL, and this Cartosat 2 satellite series, and SCATSat-1, a ResearchSat 2A, Microsat-1, HISIS, and then EMISAT, a RISAT-2B, Cartosat 3, a RISAT-2B-R1, and EOS-01, EOS-03, and 04. These are the satellites that are in service as of now. You can see here, this is another important application that we'll use. We'll take the pictures of this Earth if you want to see what kind of minerals are there, what kind of geology are there. Based on these things, this is the image that you can check this. Based on the image information, that they are actually taking what kind of minerals are there on this. Okay, there's a quartzite, a limestone, and then a shale gas, and then quartzite. These are the various minerals that are present. Because these various minerals are present, the image is actually different for different minerals. Based on the analysis of these images, we will actually figure out what kind of minerals are there in a particular region. And now let's move on to another one. This is application, that is a meteorological satellite that are in service for meteorological satellites. The INSAT 3D and INSAT 3DR are the meteorological satellites that are in service as of now. So what are the future Earth observation satellites and meteorological satellites that we are going to launch in the near future? So these are the satellites EOS-5, EOS-6, 7, 8, and the ResearchSat 3 and 3A. and the research SAT-3S or 3SA, NISAR, HR-SAT and INSAT-3DS. These are the future satellites for Earth observation and meteorological missions. Now let's move on to another application, that is satellite communication. The satellite communication, this INSAT series of satellites are used for satellite communication. This SATCOM and the recent 𝗪𝗚-𝗚𝚔 constellation of satellites in various areas of national development and tele-education, telemedicines are standing in this. The television, DTS broadcasting, DSNG and VSAT are the unit capabilities in terms of the coverage and outreach of these type of satellites, these communication satellites. These INSAT satellites are used in all these things. Apart from this, we will also use this for village resource center and disaster management systems. We will be using this INSAT series of satellites. So INSAT series of satellites are used for communication satellites. So SATCOM will also talk about the 𝗪𝗚-𝗚𝗔 constellation in detail now. Let's move on to another one, that is application. This communication satellites that are in service are that GSAT-6, 8, 9, or this GSAT-9 is also called as South Asia satellite, and GSAT-10, 11, 14, 15, 16, 17, 18, 19, 29, 30, 31. So what are the future communication missions of this satellite? That is CMS-03, GSAT-22, GSAT-23 and CMS-02, CMS-04, that is also called as IDR-SS-1 and IDR-SS-2 and GSAT-32. These are the future missions of ISRO when it comes to the INSAT series, that is the communication satellites. So this navigation satellite, I'll just cut that. So far we have talked about the different types of launch vehicles, India's launch vehicles, and we also talked about the fuels that are used in the launch vehicles. Apart from that, we also talked about applications of the satellite, that is Earth observation satellites and meteorological satellites. What are the meteorological applications that we have talked about? We also talked about INSAT, that is a communication satellite. Communication satellites are nothing but this is the INSAT series of satellites, and we also talked about communication satellites that in service, and we also talked about the Earth observation and meteorological satellites that are present in service, and also we talked about future communication missions of this. We also talked about the future missions of the Earth observation and meteorological satellites. So the next application is navigation systems. This navigation systems, that is a satellite navigation, that is also called SATNAV, is one of the main important programs of this department. There are two main components of this program. They are called GAGAN and navigation with Indian constellation, that is called NAVIC. These are the two important systems for this. So this GAGAN is nothing but the GPS aided geo-augmented navigation, that is the GAGAN. This system is developed by ISRO together with AAI, that is Airports Authority of India, to deploy and certify the operational SBAS, that is called Satellite Based Augmentation System, for the Indian flight communication region. So with the expansion capability to neighboring FIRs also. The flight information system, that's we use this GAGAN systems. So this GAGAN is presently operational with 3 signals in space. So from this 3 geo satellite, that is GSAT-8, GSAT-10 and GSAT-15 respectively. And this NAVIC-IC, this is an independent regional navigation satellite system developed and maintained by India itself. This is used for Indian maritime ships. This Indian ships are using this navigation systems now, so that the ships will be used by this NAVIC satellites. This NAVIC satellites is providing two types of services, that is namely standard positioning system, that is SPS, and the restricted services, and this restricted services is used for military navy purposes, and this is expected to provide a position accuracy of better than 20 meters over the primary service area, and the timing accuracy that is better than 40 ns. This IRNSS system consists of this ground segment and space segment and the user segment. The ground segment is the segment that is operational in various India's centers, and this space segment is nothing but the satellites, and the user segment is nothing but the users of this NAVIC 𝗖𝗍, that will call as a 𝗳𝗍. This NAVIC space segment constellation is configured with 7 satellites. The 7 out of 7 satellites, 3 in geosynchronous orbit and 4 in inclined geosynchronous orbit, that is IGSO. And another application that is used is a space science and exploration purposes. In this space science and exploration, 𝗧𝗦𝗔𝗧 is the first mission study. It is used to study celestial sources in X-ray, optical and UV spectral bands simultaneously. And there is another mission is Mars orbiter mission, that is MOM. This is the first interplanetary mission to planet, and it is to design and realize this spacecraft with the capability to perform earthbound maneuvers, and then the Martian transfer trajectory, and then the Mars orbit insertion phases, which means that when you send a satellite into the space, so within the space, within the Earth's influence, so we have to maneuver the satellites, we have to change the orbital's position. In order to do that, all these things called earthbound maneuvers. Once you go out of the influence of the Earth's orbit, then it actually enters into the Martian transfer trajectory and then the Mars orbit insertion. These how to insert a satellite into the Martian orbit. These are the things that are performed in this MOM mission. So these, and apart from this, that the deep space related mission planning and communication management at a distance of nearly 400 million kilometers. So when you take the satellites into at a distance of 400 million kilometers, we need to have some sort of autonomous fault detection and recovery mechanisms also. So these technologies are performed and tested in this MOM mission. And the next application is a Chandrayaan-1. We all know that India's first mission to moon is Chandrayaan-1. This Chandrayaan-1 spacecraft was orbiting around the moon at a height of 100 kilometers from the lunar surface. For chemical, mineral and photogeological mapping of the moon, we have sent these satellites. The spacecraft carried 11 scientific instruments built in India, USA, UK, Germany, Sweden and Bulgaria. And another application that we have with Chandrayaan-2, it will be advanced version of the previous Chandrayaan-1 mission to moon. So it is configured as a 2-module system comprising of an orbiter craft module and a lander craft module carrying the rover developed by ISRO itself. Another future missions is Gaganyaan. This Gaganyaan is for demonstration of human space flight with a crew of 3 astronauts to 400 kilometers. So this 400 kilometers is a LEO. So what kind of launch vehicle that we are going to use is GSLV Mk3. So this mission is to develop the capabilities of transporting humans to space and bring them back to Earth. So this is the objective of this mission. And another future mission is reusable launch vehicle. So reusable launch vehicle is nothing but it's a series of this mission, under this mission, a series of technology demonstration missions have been considered as a first step towards realizing this two-stage to orbit a fully reusable vehicle. So what are these two stage? That is 𝗂𝗏𝗃 that is a reusable launch vehicle. This ISRO accomplished its maiden, that is first 𝗂𝗏𝗃 mission on May 23, 2016 from Satish Dhawan Space Center, 𝗓𝗏, and successfully demonstrated this critical technologies for this design and flight testing of these re-entry vehicles. However, it was a suborbital flight. That means this flight has not completed the full cycle of this orbit. You can see this since it is not completed a full orbit, that's why it is called suborbital. You can see this orbit, it went up to here and then it came back like this, but it is not completed one full orbit, that's why it is called suborbital. So the major challenges of this orbit technology has been successfully accomplished by this. You can see this satellite has launched up to this and then it is brought back, and then we have got onto this earth, and this we have technology, this technology we have used. And then the next one is this RSL learning experiment, that is LEX. This is one of the critical technologies to be demonstrated is approach and autonomous learning on the runway. Now to acquire this end-to-end RLV, so this is another technology that RSLV landing vehicles learning experiment. This will be used, it will take the satellites and the humans and then it will bring back, and this entire cycle would be completed with this technology. This is a RLV orbital re-entry experiment. These are the experiment that we are going to do, and once it is completed, and the another mission that we are future mission is air breathing propulsion. This air breathing propulsion is nothing but the fuel that is used as a air itself. The air is taken and then air is also released. With the scramjet technology, we will be using this air breathing propulsion. So with this we will be completing this space technology here itself. Thank you.